All right. Well, in honor of Pi Day, I figure we start with a Pi question.
Oh, perfect.
Pi is an irrational number. What does that mean?
Becca, I think you always had a good explanation. All I can think of is that you can write it as a ratio or a fraction, but I know you had a good explanation for that before.
Okay. I usually go to my screen. I didn't even know. I don't need my screen, I guess, for this one. So a rational number, maybe I do want my screen. Hang on one second here. I do, because I want to break down that word there. So there are two types of numbers. You've got rational numbers, you've got irrational numbers. And rational numbers, as Nathan mentioned, rational, and as soon as my stuff comes up here, we'll do it. It's a little bit slow today. But a rational number, ratio, is in that word. And the word ratio means fraction. Here, I'm almost up here. I totally rely on this so much. All right, I'm up now. All right, here we go. So rational number has this word ratio in it, which means it's any number that can be written as a ratio, meaning a fraction. So it doesn't mean that it has to be written as a fraction, but it can be written as a fraction. Decimals count as ratios, because if you think about a decimal, let's say I had something like that, that's the same as 2/10. That is a fraction. Or sorry, 2/100, my bad. That's a fraction. So decimals are also rational, but they have to be terminating, meaning ending. So they can't go on forever.
What about repeating numbers, though?
Repeating numbers, well, repeating number, here's an example of one. So let's say I had, well, it's not a very good one. Let's say I did 0.7 repeating. That actually can be written as a fraction.
Right.
So that would be the same fraction as 7/9. So a repeating is okay, that's rational, but it has to be non-repeating to be irrational. So repeating, yep, that can be written as a fraction, so therefore it's rational. Irrational, I guess the definition of irrational officially would be it's non-terminating, so that means that it's a decimal that goes on forever and ever and ever. And then it's also non-repeating. So it doesn't have sequences of numbers that repeat themselves. Like, for example, 0.7777, that has sequence that repeat themselves. Another example of this repeating would also mean, let's say I had 0.676767. That has a series of numbers that are repeating themselves. So even though the 6 isn't repeating the whole time, the 6-7 is repeating. So that is also a rational number. So it is rational, back to that definition here, is non-terminating and non-repeating decimal. A lot of times square roots are irrational numbers. If you're wondering for an example, like if I did the square root of 2, you type that in your calculator, it's going to be a number, it goes on forever, and it doesn't ever repeat the sequence of decimals. So,
do you know the trick for writing repeating decimals as a fraction? I just learned that the other day and thought it was pretty cool.
It's over 9, over 9s.
So 9, the number of
so
nines
if I said
based
like
on like how many digits are.
0.67 repeating, it would be 67 over 99.
Yeah.
Right.
I literally just learned that. I had no idea how to do that.
Yeah, I didn't learn it in school. I learned it
Yeah.
actually when I was tutoring math. But yeah, repeating decimals are always over 9s. It's kind of interesting.
Yeah.